mic. So as long as everybody can hear me. Last week, the Kafka Summit, we had the Kafka Summit in San Francisco. There's 1,200 people there. I was the MC. It was 2 days, right? It was Tuesday morning and Wednesday morning. And I have one job, right? Like one job. I just be funny for 5 minutes and introduce people, and that's it. I lost my voice on the second day. It was not a pretty sight. It's mostly back. If I kind of crack occasionally, that's fine, but I feel like I can do okay in the room. As long as you can hear me in the back, yeah, we're good. All right, well, we're gonna talk about KSQL tonight. We're gonna talk about Kafka tonight. I would like to say thank you to the Milan Kafka meetup for inviting me because, guys, this is my first time in Italy ever. Like, yeah. And it's like, I'm ashamed of that. I traveled so much and it took until now to get me here. So thank you very much for making it possible. I'm delighted to be here. And if I could just go over here for our live stream audience, I'm delighted to be in Milan and Italy. I took a train here. 3 people, all shout out to you 3 people. I've seen a lot of train stations. I was not prepared for the Milan train station. And I was in such a hurry to get here. And I'll stop telling travel stories and get to KSQL in a minute, but I can't help myself because here's the deal. I was in Budapest yesterday, speaking at a conference yesterday. And sometimes there are some, even if it's like fairly big cities, like city to city, there's no good airplane route. Like I live in Denver and the place on the East Coast where my daughter goes to university, you're just going to burn a whole day, right? It's not like it's that much distance, but it's not optimized for that. And as it turns out, Budapest to Milan, there wasn't like a good airline route that we thought. My wife was with me, so we said, "Hey, let's do a night train." Genius, right? And we don't do night trains in the US. So like that sounds really cool. So we did that, and that was fine. And it was an hour and a half late, and there were trains canceled, and then trains delayed, and everything was bad. And basically, I walked in here 4 minutes before I was supposed to start speaking. So I think new personal best for distance and timing and all that. Anyway, great to be here. It's important to me that we talk as much as possible. So it's completely appropriate. If you have a question, put your hand up and ask the question. I don't want you to hold questions till the end because then the context is missing and you have to try to recreate it and everything. So just put your hand up. And if it's something that we can't talk about, that would just take too long, I'll say no, and we'll talk about it later, right? But it's much better if you try and put your hand up and we can just converse. So this being a Kafka meetup, who here feels fairly experienced and comfortable with Kafka, whether you're running it in production, but you know it well? Okay, who here feels like you're pretty new to Kafka? Okay, who here just doesn't like raising your hand? Or maybe you're in the middle somewhere. All right, so I'm gonna give you a little bit of Kafka basics. And I want you to in the world and why you would want a thing like KSQL. I mean, you a SQL that runs on data in Kafka. Like, I don't think I'm giving away a surprise by telling you that, but why that's valuable, I want you to know. I kind of want you to understand what Kafka is. And there are some properties that Kafka has that cause it to have, like I say, it has an agenda. It wants you to build systems in a particular way. And this is really sneaky, right? Kafka 8 years ago, when it was brand new, people used it as a pipe. There's a big pipe to get stuff into Hadoop. People don't really do that anymore. Or at least maybe legacy stuff. You don't not a lot of new designs dumping data into HDFS. That's where it started. And now it's this really interesting thing that is encouraging a very different approach to architecture. So I want to get that idea in your head so you know why you would care and why there is a KSQL. So every Kafka system that you ever build, every Kafka component will always conform to this architecture diagram. This is the simplest, most elemental Kafka architecture diagram there is. In the middle, you have a cluster, a Kafka cluster. Kafka is a distributed message system or a distributed log brokers. And to get stuff into the cluster, you have a producer. Am I pointing when I could just do this? Yeah, there. Stuff out, you have these applications called consumers. Okay, Producers put things in, consumers get everything that we build on top of Kafka is a producer and a consumer. It just has to be, right? Whether if you know the platform well, like Schema Registry, Connect, Kafka Streams, all those things, they're all just producers and consumers. You put stuff in, you get stuff out. And the things that you put in are very, very simple. On the face of it, Kafka data modeling is very elemental. You put messages or records or events, you can call them whatever you want. You put those into the cluster, and those are just a key value pair. That's it, right? Now, the structure of the value is sometimes kind of interesting, and that's actually a big topic on its own. This, okay. Sorry, the structure of the value can be interesting on its own, but messages are just key value pairs. They get organized into things called topics. That big box in the middle is a topic. And if you've ever done any kind of messaging system before, or if you've taken a data structures class and you know what a queue is, you kind of have the idea of what a topic is. It's an ordered collection of messages. But Kafka does this a little bit differently in that it lets us scale out a single topic. Ordered collection of messages can get partitioned. Each one of these partitions can be stored on a different broker, a different machine. So we're able now to horizontally scale a single topic. There's a few different reasons you'd want to do that. Two of them are pretty obvious. Number one is if there's just a lot of messages, right? You're publishing a lot or you're reading at a very high rate. Well, you might need more than one computer to do that, right? Also, storage. Reading a message from Kafka doesn't make it go away. So it's not a queue. I was just interacting with some content that we were writing for one of our sites online. Oh yeah, I didn't say what I do. I forgot that whole thing. Can we just keep streaming? We got my name. I'm Tim. I work for Confluent. You got that. I run the developer relations team at Confluent. So what we do is stuff like this. I have a team that runs meetups globally, and so working with sponsors locally and organizers locally and making pizza show up and all that kind of stuff. Also, tutorials, documentation, blog posts, all that kind of stuff. We create materials that we try to make it easy for you to adopt Kafka and the Confluent platform. So we explain this stuff a lot. And somebody today kept referring to these as queues, Kafka queues. You don't really want to think of it. Pretty simple. I refer to this as Kafka assembly language. Put a message in, get a message out. That's fine. You can build stuff that way. But you have to consider what's going to happen. Like, what are you going to do in real systems? I've actually asked rooms full of enterprise architects this question, like, what do your teams do? What do your consumers do? It's, well, we have one stream and we enrich it with another stream, a lookup table, and we group things and we filter things and we aggregate things. They kind of got sad, right? Like, oh, there's not really much to my life. That's all I do. But here's the thing, like we all write those same consumers. That's what's going to happen. It's going to happen. But the consumer API doesn't help you with any of that stuff, right? Like if you want to go, here's a stream, here's a message. I want to go basically jump to a table. That can help you with that. And either aggregate or collect things in the values of that hash table. All of a sudden, now you have a distributed state problem. You have maybe if your grad student, you're saying that equal in just a minute. That's kind of where scale, because this question is going to come up. The way this works, I've got 3 partitions here, and I could have part of these consumers, and that consumer, all of the messages from all 3 partitions. But when I add a second one, Kafka says, oh, I see you. You're just another instance of this application. I'm going to give you one of these partitions. So it lets you scale out your consume. I could add a third one for consumer group B or a third one for consumer group A, and Kafka would assign a partition to that instance of the consumer group as well. So for free, and this is you literally have to do nothing in your consumer code, you get this horizontally scalable, moderately fault tolerant consume side application. Kafka just does that partition assignment. What it doesn't do, don't tell the streaming folks, it doesn't help you manage state. at all. So like I said, if you're grouping or doing any kind of stateful work in the consumer, just using this assembly language level consumer API, you get no help there at all. So you will have to manage your own state or graduate to what we're going to talk about in just a minute. So that's the basic idea. Put stuff in, get stuff out. The fact that it's not a queue, it's a log. Okay, it remembers data. And it doesn't just remember it for a day or a week. It remembers it for as long as you like. It can be infinite. You can never forget messages in Kafka. Don't tell the GDPR police. By the way, I know they're not down here, but if you know them, I would just like to talk to them. And a set of sophisticated answers to GDPR and Kafka that are not our subject today. So it's not like you can't build GDPR compliant systems on Kafka. People do it. Anyway, the Kafka's a log, and because it's a log and not a queue, it's itself to the center of systems, is what it does. You end up with, I'll go back to that in a minute. You end up with a giant around that log, processing each event stream in whatever ways are interesting to each individual service. A service will consume some event stream, like, I don't know, validated orders, and then it might produce some new event stream, like big spending customers or something. You know, it'll find who the valuable customers are and produce a new stream of those. So you get Kafka finding itself not as a pipe bringing data in somewhere, but as a globally distributed commit log in the middle of a system with all of these kinds of services grown up around it. Now, the purpose of this slide is to show when we write to a topic, the message always goes on the end. It gets a new offset. That is literally just a 64-bit integer. Consumers, all they do is read from an offset, and then the next offset, and the next, and the next. But because consuming doesn't delete messages, I can have many consumers reading from different parts of the log. That's fine. I could start up consumer C that wants to start analyzing data from the beginning. Maybe there's a billion messages in this topic, but it's going to start at the beginning and read them all and come up with some new analysis of them, whatever it might be. I can have any number of consumers within reason that I want. When I produce messages, they go on the end here because this is a log. Messages are immutable. They can go away. I can have them expire after a certain time, or I can come up with ways to make them go away or appear to go away for regulatory purposes. But once written, I can't go rewrite them. Any questions about the architectural basics there before we jump into KSQL? Well, I don't know what I just did. There, okay. All right, let's get into the goods. KSQL is a streaming SQL. So it's a SQL-like language for processing streaming data. And I know you know Kafka is a messaging system. I know it's for dealing with streams of data, but it's worth parking on that word for a minute because we don't all know natively what that means. All right. In a database, there is a certain number of records that are, I like to say, in a place. Okay, there's a named table, and each record has an identifier, and it's there. You take data and you put it somewhere. And when I go to do analysis on that table, I can know right now, here's how many things are in this table, and I'm going to be done. I can do a full table scan. I'm going to get to the end. And it makes sense to talk about the end of that data. It is, we could say, bounded. Messages coming into a topic or streaming data, it doesn't ever make sense to say that those messages are done. We say that streaming data is unbounded. There can always be a next event. Just like you, right? You might say, well, you know, this is how many anime Blu-rays I have. I've got all of them here. And that's a collection. I know I can get to the end of it. But things are going to keep happening to you all day and tomorrow and the next day until you die. We don't need to go there tonight, at least until dinner comes. But Unbounded data, there's always more events, right? So a query on unbounded data is a continuous thing. So I define some kind of filter or aggregation or enrichment over input streams, and it doesn't finish running. And you'll see that in the demo. I will have to hit Control-C on queries. It feels broken when you first do it. And I still remember, this was over a year ago, the first time I used KSQL, I had to hit Control-C. It felt like it was broken and I was fixing it. It's not. These are continuous queries. They start and they never stop until you stop them under normal circumstances. So that's what streaming SQL means. These things are things that go on forever. Skip that. Let's go to here and start looking at actual KSQL code. Now, you would have no way of knowing that this is not SQL, right? I mean, it is syntactically. But this thing called clickstream here isn't a table, that's a stream. That's a lightweight abstraction over a Kafka topic. So, and you get the idea, this is clickstream data, so there's some little JavaScript malware out on our front end that's finding when people click or mouse over, and it's posting those blobs of topic. So anytime somebody does a thing on our website, that causes a piece of JSON, a message, to appear in the topic underlying clickstream here. SQL creates its layer on top that says, yeah, there's the top schema. And I'll show you the DDL for creating a stream later. But for now, that's just a stream. That's an unbounded sequence of events. And what is this query doing? It's filtering. So this is a stateless filter on those clicks. Agent, that makes sense if it's clickstream data. And we are wanting to know only the IE6 users. So only what those IE6 users are doing. Frankly, I would want to keep my eye on them. Anyone who's still using IE6, like maybe they're just really, they don't deal well with change. Maybe they're up to something. And we should keep an eye on them. So that's my thoughts there. Anyway, that's what this query does. And this will continue to produce those results until we stop it. Let's make it more interesting. All right, skip that first line. It'll make sense in a minute. This is a join. Select user ID page action from clickstream. We already have clickstream. Left join on users. And the join condition is fairly predictable, right? When the user IDs match. What is that? Oh, somebody has been reading his Kafka Streams documentation. I appreciate that. Or watching some really good tutorial videos that can be found online. It's not a stream. It does have a topic under it. And why is that? Because, well, it's Kafka and that's all you've got. Okay, the only data storage bucket thing, object is a topic. So underlying this is a topic. Underlying it also happens to be a K table. We'll talk about K tables right now. It's a table. Just think of it as a table. Intuitively, what else can it be? Right? These are events. And that all made sense. Like that first slide, that clickstream, you're like, it's a stream, and like nobody is bothered. You're all like, yeah, of course, it's a stream of clicks. I get it. I could do this. And then I'm here, like, well, users are things. They're entities. They have an ID. Like I have a passport number and an employee number. There's ways to identify. I'm an entity. Entities go in tables. Entities don't go in streams, right? That doesn't quite make sense. So that has to be a table. But let's think about what that means. Now, in a database, when I've got a table, say just relational database, pick your favorite. Like, let's just keep it simple. SQL-like's been in the news this week, last week. When I have a brand new table and I make an insert on that table, what's the first thing, if you examine the right path of the database, what's the set? Probably before that, it's going to log the write. Yeah, it's gonna say, here's somebody's tried to mutate the table, put it in log. And now I've got all this work to do, integrity checks, Maybe I have to find storage space. I have to go update indexes. Let's log it and tell the client that it was successful. Same thing. Any insert is going to log the update. Any update, a delete, all those get logged, right? So it's kind of like there's this stream. Now, it's a pain to query a stream because all you can do is go through it. You don't want to do that. So the database, being a useful thing, builds up a table that represents the current state of all those entities. So there is that thing, but it started as if you topic in Kafka, it's the same thing. Every time somebody updates the user record, you produce a new record to that user's topic, where the key is user, or is creating a table that represents the current state of that thing. So maybe I just updated my user profile 20 times, and there's 20 messages in there with user ID 24601, and here's Tim's user profile, right? Most recent one matters. So we take a stream and we convert it into a table. Conversely, you can always take a table and convert it back into a stream, right? There's a duality between stream and table. They're one to another. So that's what that is. This is an in-memory of serialized from a topic. Make sense? Any questions? Usually, this is the hard thing when you first get into KSQL. So if anybody has a question and you just don't ask it, you should get over it, and then I'll go on. Yeah. Yes, any underlying the table, let's call it the user's topic. The user's table gets updated right away. So it's like consuming, there's kind of like a consumer on that topic that's updating this in-memory thing. Always the latest, yes. If several messages with the same ID are produced to the topic, we only want to see the latest. And that's a bug. I mean, that's what table means in KSQL terms. And by the way, if anybody knows Kafka Streams, if you are Kafka Streams people, it's for your own mental well-being. KSQL is a Kafka Streams application. It's just built on top of Streams. So under the covers, if you don't know what Kafka Streams is, you could just pretend I was speaking Hungarian just then because I was in Budapest over the weekend and I learned really fast. It doesn't need to mean anything. You don't need to know Kafka Streams to know KSQL at all. All right. So every time this message, a click shows up, we look here for the user, join them, filter. So I'm only looking for platinum people. Remember this top line? I said, forget about it. Well, let's come back to it. What this means is establish this as a permanently running query in the KSQL engine. I'll tell you what KSQL engine means in a minute, but just imagine there's some computers out there running a program. And produce the messages, the results of this query, produce them to a topic called this. So it starts as topic data and it goes back into a topic. You just don't have to do any of the table creation, any of the state management, any of that stuff. You read, you consume stuff, and you produce stuff back out. And it's in a topic. You can do anything you want with it. You go write your own consumer. You go use Kafka Connect to dump it into a database, anything you need to do. It's just a topic. It's just data in Kafka. And because this is stateful, obviously, I mean, it's the very definition of state, I can lose a node in my KSQL cluster. Remember, it's going to look a lot, we'll just go back all the way to here. It's going to look a lot like this, right? KSQL is running in machines that are connected to Kafka. I can lose one of these, and the state that it had in there, it has actually been replicating to an internal topic inside the Kafka cluster. So when I replace that node, it'll say, oh, okay, well, just pull this state in and pick up where I left off and go. Of course, anybody who operates this, real life is a little harder than that. That might take an hour, who knows, that could take a long time. But in principle, states manage. Question? Yes. 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 So in this case, this is a table that started life as a topic. So we kind of don't need to worry. We can always reread that topic and recreate this table. Sometimes we create tables though, like, I don't know, in this next slide. And when we create a table, then that is unique state that is being replicated back into the Kafka cluster. It's actually two places. It's getting flushed to disk locally on the KSQL node. So if you just take a reboot and you have persistent storage, you can just swap it right back in. But if the node goes away entirely, then you can materialize it from the KSQL, from the internal topic. So basically, your distributed state problem is, you have a distributed state problem, and it's as if KSQL says, I wish we had a replicated distributed fault tolerant state store lying around. And well, you do, right? There's a Kafka cluster. So it just uses Kafka for that. All right, let's walk through this query, and then I'll show you some DDL, and then we'll do a demo. Sir. Ooh, good question. Is it possible, for those of you joining us via streaming, how many are we up to now? I love both of you. So the question was, what if there's not enough memory to keep the whole table? Because sometimes there won't be. They're not, in general, there never is enough. Two things. Number one, the memory that Kafka uses, that KSQL uses for those things is off heap, so that makes life a little less terrible. Number two, we can scale these out. Just like a consumer group, I can add more instances of my Kafka cluster. And as long as I've got partitions on this table or this topic, then I can partition. I can keep scaling out my KSQL cluster. So if you have an enormous table, that's a challenge to fit in memory. You just have to kind of radically scale out the KSQL cluster. For real life scales, like 20 nodes in a KSQL cluster is a lot, just for what actual people are doing with this. 5, 3, those are in practice things that, as of at the time of this late 2018, those are what people are seeing. So will my table fit in memory is not something that comes up a lot, but the answer is scale out and scale up. Something like a, no, there is not one in here. The question is, do we need a log structured merge tree? And KSQL does not have one. However, okay, kinda. This topic, Kafka will let you configure topics to delete data after it gets too old, and you set what too old means, or compact topics if you see the same key. So I don't think it's precise. Like I've actually never thought about this. I don't think it's correct to call it an LSM, but you get similar characteristics in that previous versions of a given key will go away. So that's on disk storage. That's not in memory. They always go away in memory, but on disk you can save space. Question.
Is it using RocksDB?
The question from Mateo is it using RocksDB under the hood? Why, yes, it is using RocksDB. So by default, RocksDB is the internal state store of the API's underlying KSQL. It's pluggable. If you wanted to use something else, you could, but in practice, if you're using KSQL, you probably don't want to do that. Like you're good. And because it's pluggable, like you should expect that to evolve as KSQL evolves. They're as always with any component that you grab from the open source world and plug in, there will be little points of friction over time. And 2 years from now, that question will come up and somebody will probably say, well, no, as of KSQL 8.0, it's blah, but it's pluggable. So it's fairly easy to do that. And I've actually talked to people who have swapped in other things just for fun. All right. One other thing This might be too much, but you guys are doing okay. This is a topic. It is partitioned. Yes? This underlying is a topic, also partitioned. They must be partitioned the same way. Must be co-partitioned, meaning same number of partitions in this underlying topic as this underlying topic, same key, which in this case is going to be user ID. That way you know for whatever node in my KSQL cluster partition X is assigned to, partition X of users is also going to be assigned to that same node, and all of the same keys will be there. So you have to co-partition. Sometimes in the demo, I make a mistake where I don't co-partition them and I have to go undo some things. It's tedious, and hopefully you won't see me do that tonight. It's just not worth it. But maybe I will, and you'll see that you really do have to co-partition tables and streams. All right, 3 more queries. They won't take as long. I will show you a slide for that. The answer is it always can be. It just may not have been yet. So we'll get there. All right, here it's a different domain. We have credit card authorization attempts. They say, my credit card company says, aha, Tim is traveling again. We better cancel his credit cards right now, just to make life easy for him. So this is a topic. The events coming in are people trying to authorize credit cards. And what we're doing is grouping. So this is an aggregation. We're grouping by card number and saying anytime we see the same card number appear more than 3 times within 5 seconds, that's what this window line means, then that card number is flagged. It goes into the table as possible fraud. And it stays there, right? This table is going to show you if a card ever had 4 transactions or more within 5 seconds, it goes in the table. It's just there. And this table, we're now creating a table. There is a topic called possible fraud that is created in the Kafka cluster. And every time I insert or update a row in this table, I produce that message to the topic. So I could have some other KSQL query create a new table from that topic. Like if it's some other KSQL cluster, some other part of the company, say, hey, possible fraud, great. I'm going to make a table out of that. And I can just materialize that table. I've turned a table into a stream, back into a table. Windowing is actually fairly complex. There's if you go on YouTube and you search for KSQL windowing, that'll probably get you there, actually. There can't be too many of those. We've got like about 10 kinds of windowing. It's difficult. So I'm just going to leave this here because we want to talk about this. If you don't have the right partitioning on the topic, simply repartition it. I'm going to demo this in a minute because frankly, you're probably not going to in general. You probably will given topic and repartition it into other topics in service of different kinds of analysis that you didn't anticipate when you chose the original partitioning scheme. And by partitioning scheme, I mean really key. And that's you're making copies of data. Why is that okay here? Because what? No, making copies of things in memory is awful. You should. Well, you can. Hopefully, you can afford it. At some point, you can't. I mean, we say we're kind of cavalier about this. Like, oh, disk is cheap, and blah, blah. You know, yeah, it is, but copying things still takes work. You know, and you have to store it somewhere. It's because they're events; they're immutable. The things you're copying are things that cannot change. So it's okay to copy them. The only cost of copying them is the cost of copying them, the moving of the data, the storing of the data. You don't have a data integrity problem because they're immutable events. And so that whole thing, if you're a student, if you're an undergraduate, you're taking a database class, you have a professor that's convincing you that it's immoral to duplicate data, just roll with it, okay, get your degree, and it's not. I mean, copy it until you get tired of copying. Now, finally, DDL is very, very simple. So I say create stream, click stream, columns, data types. You've seen it. And I'm creating the stream on, and whether it's JSON or Avro data. I'm going to be using all JSON data today because it's easier to look at. Can I do a demo? Do we have time for a demo? We do? Okay. I have to go off camera from the demo. But actually, true fact, I like being on camera. But let's just do some things here. Mirror. Hey. A year ago in August, there was a total solar eclipse about a 4-hour drive north of my house. And I went there. And funny thing about highways, I think there's a here. No, you might want to make your text too wide. Too wide? What? You said please. Come on. Yeah. So, you know, I might want to, but then I might not be able to.
Can you see them? All right. So
yeah, this is
colors. Color, please. Light background. There you go.
There we are. All right, everybody see that okay? All right. Huge fans. We're going to need 2 of these. Show you which data. We'll go over here and we will SQL start it up. Now I've got pretty exciting. There's only about 910, 920 films in it. There's a lot of metadata, way more metadata than we're going to use. And I've got a script that's going to produce. All right, it's going to be actual streaming over and over and over again. Centered, sensible values for each film that have been chosen by someone with impeccable taste. That's me. But yeah, so that's the stream. And this really is a table, right? Let's see what we can do with these things. Now, oh, good. I've got KSQL fired up here. KSQL lets me see, like, those are the topics I've got on my Kafka cluster. Those are just kind of that are there to they're there by default for the parts of the platform that I've started up. And what I'm going to do is, let's see, I'm going to take a single message from that movies file, that's best, type that into a command called KafkaCat. All right, if you don't know KafkaCat, but you do know Kafka, you know KafkaCat now, and that's part 1. Part 2, you're welcome. This is written and open sourced by a coworker of mine, fantastic guy, and this is a much more pleasant tool to use than the Kafka, the built-in tools. Anyway, So yeah, I'm going to produce to a topic called movies raw that one record. And now let's go over here and we say, hey, look, we have, oops, no, we don't. Let's get this thing figured out. And in case I go back into Atom, I'll get it contained. All right, everything's fine. Nobody's going to get hurt here. Now there is, bring it up a little bit more. There you are. There's our new topic, and I would like to create a stream around that topic. I'm going to call it movies raw, and I'm going to give it some metadata. Movie ID, title, varchar, and release year. That's it. There's all those directors and cinematographers and stuff like that in my movie data. Fascinating. Would love to talk to you about it. I don't want to type it. So let's see. We'll say there's an underlying Kafka topic called movies-raw, and the value is JSON. Right? All right. Another thing I have to do is this. And what this is telling really Kafka is anytime there's a new query, or in general, a new consumer group starts up, and all these queries get compiled down to be new consumer groups at the end of the day. Anytime there's a new consumer group that hits the cluster and you've never seen it before, Mr. Cluster, start it at the beginning of the topic. The default is to start at the end of the topic, which is very not exciting for demos. So I want to be able to run queries over and over again. And most of the time in production, you don't do this. It's an engineering decision which way you want to start. But pretty much all the time at a meetup, you do. Trust me. Now I can do this. I can say select star from movies raw, and I get my record. It's pretty cool. And notice it's hung up, apparently broken. You know, I can terminate it, but that's just how it works. So I go over here to my other tab, and let me produce another record. I will not be able to switch tabs fast enough. And there it is. Meet the Fockers is there. So here I'll go back to the head, and I'll do that a few times. And so it's a stream. Those things are happening, and it's fine with them being there. I can put 10 of them in, and there we get those things. I can kill that query. I can run it again. All those things are there. Now, what we have here is movie ID, title, release year, timestamp, and any guesses what null is? Key. What kind of psychopath produces messages null key? It's like I want to watch. So let me fix that. I would like to create a stream called movies rekeyed as, oops, I'm going to have to put a little something in there. We'll come back to that. As select star from movies raw, partition by movie ID. Okay, so you get to repartition. It's going to create a new topic called movie ID, or called movies rekeyed. And if I don't tell it that, it'll try to make it four partitions, and KafkaCat is using one as its default, and we don't want to be sad. So let's do that. And that's there we have it. Stream created and running. So this is actually a stream processing program that is now running in this little KSQL cluster of one. Yes, sir. Well, it's hashing always based on key. So like which hash function? I actually don't know. That's a good question. I have seen it and it never comes up, and I just never remember that. But you could, I mean, that'd be an easy thing to check the code. What's important about that hashing function is not that it's cryptographically secure, but that it's fast and its output is uniform, which if it's a hash function, its output is uniform. So it just kind of has to be fast. Nothing is being secured by that. You're just making output uniform. Okay. stream period and running. I've got a new topic. Now I have a sensible ID. But this is movies. I don't want it to be a stream. So what do? Well, I have this topic here called movies rekeyed. I could just create a table from that. A table called movies that had metadata that looked like this. Right? Rekeyed. Stop me. We're pair programming here, so stop me if you see typos. And of course, I also need to provide a key, which is the column that's going to be my key, and that's movie ID. And now I have a table. Question. This is actually kind of a weird thing in the way you do this in the current version of KSQL. That has to be, there has to be a column in the table. It also has to be the key of the topic, right? So I would expect in a future version of KSQL for this to get simplified a little bit, but right now there has to be a column called movie ID. It has to match the key of the topic, and you have to tell create table to use that key. Right, but if you have one topic, you could also just assume that the key of the topic is the key of the table, but then you have to tell it what column it is. So it's a little bit goofy, but the cool thing here is, this takes a second, but here we are, no more duplication. Now, we're getting there, about 10 more minutes. It would be, what I was saying was, it seems like we could just use the key of the topic. Yeah, but we still need a thing to call it. Yes, which is fine. Right. When it doesn't even have to be a compacted topic. That's the cool thing. Yeah. Right. And also there are circumstances under which KSQL will automatically repartition the topic. If it has the wrong key, it'll create a new topic under the covers and a producer and a consumer to set that one up. But yes. Remove or it will not let me. That's KSQL's version of referential integrity. It'll say, wait, that's being used by something that's running. There's more than one way to create a table. In this case, this is a sort of table by DDL, right? Just an overlay on top of a topic. And so, oh, hey, no, you know what? I'm sorry. I said the wrong thing. If I remove the query that's creating movies rekeyed, the table is fine. The table's going to stay there. It's just not going to get updated anymore. So that would be broken. Yeah, and KSQL can't tell if that happens. So yeah, if you are creating it from a stream and you try to drop that stream, it'll say, sorry, somebody's using it. You have to drop that thing first, but we'll get there. Okay. I have a little script here. Don't worry about what it does. It's just going to stream. So ooh, that's extremely bad. That's because, oh boy. Yeah. Somebody was doing some work. He's just going to blow it away. And hopefully everything I could have stashed, but I just didn't want to stash. I just wanted it all to go away. So suspense. This is going to stream. You better start. There we are. Okay, good. We just streamed about 60,000 movie ratings into a new topic. So let's look at what that topic is. It's called ratings. So I want to create a stream. I'll call the stream ratings. And it's got movie ID, and it's got a rating with Kafka topic, ratings, and value format. Like you're learning this already, JSON. That is unstimulating. You can't tell that I have really good taste in movies by looking at this, but I'll help you. Okay, so let's do this. Let's say select, start from ratings, left join movies. Remember, I have that thing lying around. Movies, movie ID. And I'm going to simplify this. We'll say title and rating. Now, why so many nulls? Because, let's get that query ready. I want you to see this unfold here. So I never produced all my movies into the topic, right? Capital P, topic, movies, raw. So I'm going to switch tabs quickly. I'm going to run this. You're going to see nulls. I'm going to go produce the rest of the things into the topic that the table's created from. I'm going to switch back. You're not going to see nulls. Nulls, not nulls. So real-time streaming data. You still can't really tell whether I have really good taste in movies or really bad taste in movies. You can't form your own opinion about that, right? So to do that, we're not just going to take this list of movies. We're going to have to aggregate it. So let's do that. Let's group by title. I like that. Let's group by title. And I don't want rating. I want title and the sum of rating divided by the count of rating as average. Rating from ratings left on movies on rating by title. Love it. And I'm going to create a table called rated movies as that select. So this is now has created a new Kafka topic. This program is running, process probably done, processing all of those records from that I already produced. Uh-oh, my AirPod just made its little power down noise. I'd better hurry. We only have a few minutes. Streaming people, if you're still hanging on with us, we still love you. All three of you, just, okay. Now we see averaged movies. And you can see like Goonies, anybody does Goonies? Yeah, it's a pretty good movie. Children of Men, I need to revise that. I think I'm selling it short. The Beowulf, this was, I don't have release year in here, but this is like the 2004 Beowulf, really not successful. Happy Feet, never got the menu, really. What's it? Yeah. Die Hard, Christmas classic, am I right? A Beautiful Mind, excellent film. Walk in the Clouds, highly underrated. Where's the best one ever? Tree of Life, greatest film ever made. I'm sure you agree. Anyway, you get the idea. And let's start up the ratings again. If you're all talking about films now, I want you to know that never happens in the US when I do this demo. So my hat is off to you. And so now with new ratings coming in, this table will constantly stream new values. Every time a new rating comes in, the average changes a little. It has to recompute a new average. And so it's emitting a new thing. So this doesn't look like a table, right? That's the problem with this scrolling CLI select from a streaming table. It's a little weird. Now I could take this table and dump it into some tool like Elasticsearch or Postgres or something where I could, visualize it as a table and just, sort and do all that kind of, it's there for me to do that. At the command line here, we're stuck with this. This is what it's going to do. No matter what, it's just going to stream new results. So that's the basics. You see some things that we can do with KSQL. Now, I didn't show you what KSQL runs on. I do just kind of want to give you a rough idea. I was running everything in a box, right? A single broker, a single zookeeper, a single KSQL. But in production, you deploy a cluster of those KSQL engines. It's got a REST endpoint. You throw KSQL queries at the REST endpoint, or you can give it a file that it starts up from and it'll just run the queries in that file permanently. And those are streaming queries. They run forever. They're always consuming from source topics, always producing to the output topics. That's the basics. There's a question. The question is, don't you need to provide a window when you're aggregating? You can, you don't have to. So it is okay to do that aggregation over everything. But I also have the option of providing a window. The only time I have to provide a window is when I'm joining a stream to another stream. And that's, stream joins are weird enough. They don't fit in the conference talk or meetup interaction, right? Like to get there from zero, you kind of need the 3-hour workshop sort of thing. So there's no stream join here, but it's required for a stream join that you have a window, because if you think about that, stream join means here's this unbounded sequence of events, here's this other one, I want to match things. They're infinite, right? So you do need to say, well, within an hour, if I see the order and the shipment happening, produce that to the new topics. So stream joins need to be windowed, but they don't have to be. And sometimes like that credit card fraud thing, like that was fundamentally broken without a window in terms of the behavior of the domain, but it wasn't KSQL making you do the windowing. Question there. Oh, great question. Let's go back to here. So let's say, in fact, take away the CLI. I've got these servers, they got a REST endpoint. I connect to one of them and I give it a new case. Well, the name fig file that has given it a unique name, and it has created what's called a command topic inside the cluster here. So any one of these nodes gets a new query, it reduces that to the command topic. The other nodes all keep each other up to date. The cluster gets new work, they all know about it. So that's the queries getting distributed through the command topic. Then the partitions, so those queries are taking certain topics as input. Those are partitioned, and those partitions get assigned to the nodes by the consumer group rebalance protocol as normal. More questions? This is a crowd that wants to eat pizza. Oh, here, yes, in the very back. I will pay you later. So the question was, is it possible to plug in a custom UDF written in another language? The answer is yes, if the language is Java or a relatively, I mean, it could even be Scala if you're into that kind of thing. I wasn't thinking Scala, but it could be Scala. It could be Kotlin, it could be Groovy, it could be whatever. It certainly could be Scala. That was a very subtle Scala joke, you guys should have laughed. But yes, so JVM languages, the examples that we give are Java, but we do have an example project and a tutorial video that shows you how to do that. You can write custom UDFs. UDFs act on aggregation functions that act on groups of records and do other more interesting things. Like one of the examples is a machine learning model. So there's this pre-trained machine learning model that has generated this hideous Java code that's got all the gradients in it all baked in big giant arrays of numbers. You can just access that through this UDF in KSQL. Super cool. In KSQL, have you done this? Okay. No, not yet. Yes, I was going to say. Well, could you tell me how? Right. So, no, that it will be a thing that happens, but I don't think we're there yet. And by the way, what version is KSQL? What is it right now? 5.0. It'll be 5.1 probably later next month. Released as GA in April. So let me help you decode the version number so you can think about this. And if you're a student, you don't care. If you're not a student and you want to use this professionally, you very much care. We number it. So Confluent releases it with the Confluent platform. And the Confluent platform is simple enough now that everything has the same version. We just haven't gotten into that life of there being, teams of people who manage all the versions of things. So it's all 5.0. But basically, you want to think of it as 1.1. So it's not totally brand new, but it still is young, and it's got all kinds of features like custom types and case statements. There's all sorts of things that it doesn't have that it will eventually. More questions? There. Yeah, JDBC. Again, so probably fronting it with a BI tool, that I'm not sure. I know right now that we say, don't think of it that way. Like you want to think of this as a way to build real-time analytics that can then produce real-time data that you can visualize, maybe with the BI tool. But you say BI tool, and that implies ad hoc data exploration. And we fairly explicitly say that's not KSQL right now. KSQL is for real-time streaming analytics and stream data processing. However, JDBC driver, it's kind of funny because at first I started to think about that. I thought, nope, never going to happen. And then the next week, this was like last October, somebody released a partial one, so it'll happen. Confluent hasn't done that yet. There isn't anything in the open source community that's all that well developed there. That's probably going to happen down the road. But that's, by the way, not a roadmap statement. I don't make roadmap statements. That's just, yeah, I bet someday. There's another hand over here. Yeah. Sure. So briefly, the question is compare KSQL to Flink. They're, to keep it brief, Flink and Kafka Streams, the Beam API, Kafka Streams, they tend to have a lot of parity, right? They're both very mature systems. I can't really, as a developer advocate for Kafka and Confluent things, like I like the system because it's a very mature and frankly quite competitive stream processing system that works well. And so one can solve these problems in Flink as well. Where the comparison gets me is Unix is also, and that's from an infrastructure standpoint. The insight is I have a Kafka and I could do all these things in Kafka as a platform provide process Kafka and then this other thing. So you have to have a pretty compelling reason for the other thing to create that infrastructure. And that debate needs to get carried on. People make that decision, right, to use Flink. But there's a certain economy about saying, hey, look, Kafka does this anyway, and I know I'm going to have one, so let's just keep it there. That's usually the way the argument gets made. Oh, how's the integration with Avro? Sorry, I didn't say that. It's me, the protobuf integration. I wouldn't have such a good answer. So the data formats that KSQL supports are Avro and JSON. So they're like delimited. Yep. Yep. Oh, subfields in the key. I did not say keys could be Avro. I didn't say that. I didn't say they couldn't, but in fact they can't. They can't yet. Values can be Avro or JSON, and they can be nested arbitrarily. And, sorry. No, right now, strings only. And that's another one of those kind of 1.1 sorts of things, right? Like there's no reason for that. It'll get fixed at some point. There's no principled reason. It's just haven't gotten there yet. All right. Hey, we should transition to, do we break and we do more Q&A? And what do you want to do?
We can just have a break together and keep the Q&A.
Yeah.
Streaming during
All right.
Okay, thanks again.
Thanks, guys.
And we also